The Andromeda Nebula. Photographed at the Yerkes Observatory around 1900, it's obviously a galaxy for us. Then it was described as a mass of luminous gas of unclear origin. And what is special about this date? New Year is just an accidental flipping of the calendar, but it can also serve as a moment of elevation, renewal, and revision of representations. This happened with one of the most unusual dates in the history of science. January 1st, 1925. We can say that. Nothing remarkable happened then, just an ordinary report at a scientific conference. Or it can be celebrated as the birthday of modern cosmology, the moment when humanity discovered the universe as it is. Before that, astronomers had a short-sighted and limited view of reality. As it often happens even with the most brilliant minds, they saw, but did not understand what they were looking at. And the key fact was right in front of their eyes. There were interesting spiral nebulae scattered all over the sky, whirlpools of light resembling tops. The most famous of them, the Andromeda Nebula, was so bright that it could be easily seen at night. But the meaning of these ubiquitous objects remained a mystery. Some believed that spiral nebulae were huge and distant star systems, island universes comparable to our Milky Way galaxy. Many others were sure that these were just small, closely spaced gas clouds. From their point of view, other galaxies, if they exist, were not visible and were far in the depths of space. Or maybe there were no other galaxies, but only one Milky Way, one system that defined the universe. The disputes between the two sides were so heated that they led to the famous Great Dispute of 1920, which ended in an unsatisfactory draw. The correct idea of our place in the universe appeared just a few years later, in the work of one of the most famous astronomers, Edwin Powell Hubble. Since 1919, Hubble has become one of the most patient and scrupulous observers at the Mount Wilson Observatory in California. And the observatory itself became the main vanguard of astronomical research, home to the recently created 100-inch Hooker telescope. Then it was the largest telescope in the world. It was the perfect combination of the right observer in the right place at the right time. Hubble was greatly helped by the previous study of West Melvin Slipher from the Lowell Observatory, one of the unsung heroes of modern cosmology. Slipher found that many of the spiral nebulae move at great speeds, faster than any of the known stars, and that they move mainly from us. For Slipher, this discovery was a convincing proof of the independence of these systems, attracted by unknown mechanisms, operating outside the Milky Way. But Slipher lacked the necessary resources to prove his interpretation. He needed a giant telescope, such as Hubble controlled on Mount Wilson. That's where our story switches to top gear. Edwin Hubble for the control of the 100-inch telescope in Mount Wilson. Around 1922, Hubble has always been cautious about theories and interpretations. He focused his scientific attention on spiral nebulae, without focusing on the need to prove the theory of island universes. He preferred to wait until he could present an unambiguous confirmation or refutation of this theory, depending on what the evidence points to. In 1922, another important piece of the puzzle appeared. That year, Swedish astronomer Nath Emil Lundmark saw what he considered to be individual stars in the arms of the spiral nebula, M33. Shortly after, John Duncan of the Mount Wilson Observatory noticed the points of light fading and burning in the same nebula. Could these be variable stars similar to those that exist in the Milky Way, but much dimmer because of the huge distance to them? Feeling that the answer was close, Hubble redoubled his efforts. He spent the nights in his favorite wooden chair, controlling the steel mount of the Hooker telescope to eliminate the effects of the Earth's rotation. The attempt was successful in the form of detailed images of the Andromeda Nebula with a long shutter speed. The spotted light of the nebula began to turn into many bright points that looked not like gas, but like a giant swarm of stars. The final proof appeared in October 1923. when Hubble noticed a characteristic flicker of a separate, variable star from the Cepheid class in one of the arms of Andromeda. The visible brightness of such a star changes predictably and periodically, and its own brightness depends on the period of oscillation. Just by measuring the 31-day flicker cycle of the star, Hubble could calculate the distance to it. According to his calculations, it turned out 930,000 light years, less than half of today's estimate. But for its time, it was still a shocking figure. This distance placed Andromeda, one of the brightest and perhaps the closest spiral nebulae, far beyond the Milky Way. In principle, it was then that the big dispute was resolved. Spiral nebulae were other galaxies, and our Milky Way was just one of the outposts of this stunningly vast universe. But the story didn't end there at all. With his inherent caution, Hubble began to look for more evidence. Next February, he probably discovered another Cepheid in Andromeda, several Cepheids in M33, and possibly in 3 other nebulae. And when there was no doubt, he wrote about this news to his longtime rival, Harlow Shapley, a leading supporter of the idea of small and nearby spiral nebulae, in order to tease him. "You will be interested to know that I found a Cepheid in the Andromeda Nebula," the letter began. Shapley didn't need to read further to understand the importance of Hubble's words. "This letter destroyed my universe." Cecilia Payne-Gaposchkin, a doctor candidate at Harvard, who was in the laboratory when the message from Hubble arrived, angrily said. Payne-Gaposchkin was another key figure for modern astrophysics. By an amazing coincidence, her innovative work on the star spectrum was completed on January 1, 1925. Despite the obvious joyful excitement about the discoveries in Andromeda, Hubble was still hesitant to publish the results. With all the ostentatious confidence, he was terribly worried about the loud and premature announcement of the opening. Every time, going from a meeting to a formal dinner at 5 p.m. at the monastery, Mount Wilson's living quarters, Hubble met with his fellow astronomers. Not all of them accepted the existence of other galaxies. Being a vain and carefully watching his reputation scientist, Hubble was afraid to look like a fool. Adrian van Maenen, a cheerful and cute Dutch astronomer on Mount Wilson, vigorously proved the opposite point of view. He was convinced that he observed the rotation of some of the spiral nebulae, which was possible only if they were small enough and close enough. Hubble was worried about the presence of a doubting scientist in his ranks, and held on until he gained absolute confidence in the results. Van Maenen never understood where he was wrong and refused to admit his mistake. Hubble eventually revised his colleagues' photographic plates and announced that the previously found rotations turned out to be the result of hidden systematic errors and did not indicate the movement of nebulae, real or apparent. From an academic point of view, it was a very sharp reproach. The only variable star noticed by Hubble, in the Andromeda Nebula, changed our entire idea of the size of the cosmos. On the left is the image that helped the discovery. On the right is the brightness curve of the star. Information about the discovery of Hubble inevitably leaked to the press. As a result, the first public announcement of an astronomical breakthrough was a small note in the New York Times on November 23, 1924. The most important space-related discovery in the last 3 centuries came out in the form of one news from a whole pile, and yet Hubble refrained from formal publication. Prominent astronomer Henry Norris Russell persuaded him to present his discoveries at a meeting in the capital of the American Association for Scientific Achievements, which offered a prize of $1,000 for the best work. When Hubble never offered his job, Russell hummed, "Well, he's a donkey. He gets his hands on a light $1,000, and he refuses to take it." And then Russell opened the mail and found that the work from Hubble had just arrived. And yet Hubble refrained from formal publication. Prominent astronomer Henry Norris Russell persuaded him to present his discoveries at a meeting in the capital of the American Association for Scientific Achievements, which offered a prize of $1,000 for the best work. When Hubble never offered his job, Russell hummed. Well, he's a donkey. He gets his hands on a light $1,000, and he refuses to take it. And then Russell opened the mail and found that the work from Hubble had just arrived. And only now we come to a stunning public announcement. On January 1st, 1925, Hubble was in isolation on Mount Wilson, and Russell read his revolutionary work about the existence of other galaxies in front of an enthusiastic crowd. Hubble got a part of the prize for the best work. She ended the big dispute, and not only. It dramatically increased the size of the known universe by 100,000 times. She prepared the ground for the discovery of the expanding universe. And as a result, the original Big Bang, which was already hinted at by the speeds recorded by Slipher. If it is possible to set any date as the birthday of modern cosmology, it is hers. Oddly enough, it was Schaepel, not Hubble, who suggested that astronomers adapt their nomenclature to the new reality and call external star systems galaxies. Hubble still enjoyed conservative views on the world, which he refuted. He also naturally preferred to disagree with any ideas submitted by his rival, Shapley. Therefore, Edwin Hubble, the man who proved that the Milky Way is just one of the countless galaxies, never stopped calling these objects extragalactic nebulae. Observing the cyclical fluctuations in the brightness of the Cepheid in Andromeda, Hubble expanded the capabilities of the human mind in another way. He saved us from worrying about the fact that stars that are extremely distant from us can behave differently than those in our neighborhood. Now that scientists could study stars in other galaxies, they could determine the constancy of the universe in space and time. According to modern calculations, the Andromeda Galaxy is 2.5 million light-years away from us. That is, the visible light started 2.5 million years ago. It turns out that we see the stars of this galaxy not only 2.5 million light-years away, but also living 2.5 million years in the past. Nevertheless, they look like the stars closest to us. And when Edwin Hubble and other astronomers looked even further, they added more and more evidence of spatial and temporal uniformity throughout space and all times. Atoms seem to emit the same light, and variable stars obey the same physical laws. This constancy of nature gave persuasiveness to the search for one set of rules that operate throughout space. Or, as Albert Einstein would say, showed that God does not change the rules of the existence of the cosmos. It was a damn good birthday present for the human mind.